What we have here is an easy target for fearmongers to score political points due to the problems of the global radiophobia epidemic. Is it a problem that Japan is releasing water that is safe to drink into the ocean? Certainly we don't want to see nuclear radioactive materials being distributed into the ocean frequently.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Produced by Soapbox Media.
The world needs evidence-based public policy now more than ever. Making the right decisions should not be partisan politics. Please help spread The Rational View by going to patron.podbean.com/therationalview. Together, we can make a better future. Hello, and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. In this episode, I want to investigate Fukushima wastewater, the controversy, and the polarized response. What is the controversy? Well, the operator of the Fukushima Daiichi nuclear power plant in Japan is planning to dump over 1 million tons of radioactive wastewater into the ocean. Environmental groups around the world are outraged. Protesters line the streets in Korea. Chinese government is boycotting Japanese products. Headlines scream about radioactive fish. The oceans will never be the same. What's going on? It's time for a rational view. If you like what you're hearing, please press like on your podcast app. Please share it with your friends. And come have a chat with us on our Facebook group, The Rational View. So, a little bit of background. On March 11th, 2011, a magnitude 9 earthquake struck under the ocean off the coast of Japan. It lasted for over 6 minutes. It was the fourth largest earthquake ever measured. Several nuclear reactors along the Japanese coast automatically shut down during the earthquake as designed. There were no problems. They survived the fourth largest earthquake in modern history. Unfortunately, the earthquake triggered a devastating tsunami, which generated waves over 40 meters high that swept up to 10 kilometers inland around Sendai, Japan, at speeds of up to 700 kilometers an hour. Some of these coastal reactor buildings were actually used as shelters by local residents who, in the Sendai area at least, had only 10 minutes warning before the tsunami struck. The tsunami devastated the surrounding countryside, killing over 20,000 people and displacing over 200,000 from their homes. It knocked out the whole electrical grid. Emergency services were overwhelmed. And at the Fukushima Daiichi nuclear plant, staff were overwhelmed when their inadequate seawall was overtopped by the tsunami wave, and it subsequently flooded their emergency on-site diesel backup generators. On-site staff scrambled to find replacement pumps and generators to cool the reactor core that had been shut down safely when the magnitude 9 earthquake struck, but they were unable to prevent a meltdown of the hot radioactive materials. As a result, on the 5th of April, 2011, the operator of the nuclear plant, Tokyo Electric Power Company, or TEPCO, was forced to discharge 11,500 tons of untreated coolant that they had been pumping through the cores from the ocean back into the ocean in order to free up storage space for water that was even more radioactive. The untreated water was the least radioactively contaminated among all the stored water they had on site, but it's still 100 times the legal limit. And in May 2011, another 300,000 tons of untreated radioactive water were dumped to free up water tanks. Since that time, TEPCO has continuously been cooling the cores by pumping in fresh seawater, and the core temperatures are moderating. The UNSCEAR, the UN Scientific Committee for the Effects of Atomic Radiation, the scientific panel in charge of monitoring nuclear power and nuclear disasters, reported in 2020 that direct releases in the first 3 months after the meltdown amounted to about 10 to 20 petabecquerels. That's a unit of radiation. 10 to 20 petabecquerels of iodine-131, which is a radioactive isotope of iodine, and about 3 to 6 petabecquerels of cesium-137. Now, a becquerel is a unit of radioactivity equivalent to 1 disintegration per second. And petabecquerel is using the metric system. So 1 becquerel is 1 per second, and then there's kilo, which is 1,000, mega is 1,000,000, giga is 1,000,000,000, tera is 1,000,000,000,000, and peta is 1,000 trillion. So that's a lot of disintegrations per second. That's a lot of radioactivity that was released in the early stages of this disaster. These units are immense, and we need some context to understand them. To put it into perspective, the Chernobyl disaster released a total of about 85 petabecquerels of cesium radiation, mostly into the air. So that compares to 3 to 6 petabecquerels in the water of Fukushima. So, 10 times more of this was dispersed in the air at Chernobyl. Long-lived isotopes from open-air nuclear weapons testing have contributed another significant amount of radiation to our environment. So there is a lot of radiation in our environment. Nuclear weapons testing has 400 petabecquerels, roughly, of radiation in the biosphere. These pale, however, in comparison to natural sources of radiation around us and in the ocean. Uranium and potassium are dissolved in the ocean water from the rocks underneath, and these contribute roughly 39,000 petabecquerels and 15 million petabecquerels to the ocean, respectively. So at this point, natural radiation dwarfs man-made radiation in the environment. However, man-made radiation is a pollutant that can add up and in concentrated areas cause health problems. Just to give you a little bit of more background on this, because it's difficult to understand what the real risks are. So I mentioned iodine and cesium as two of the main components that were released. And these are the important ones that can have problematic health effects. Radioactive iodine has a half-life of about 8 days. And it was the main cause of radiation-induced thyroid cancers in the 1986 Chernobyl disasters. And a half-life means half of the radiation is gone every 8 days. So after about a month, most of this iodine is no longer dangerous. But in the first month, you need to be very careful of what you eat because iodine can fall out on the grass. Cows can eat it, it can get into cow's milk. And the residents of the Chernobyl area were not warned to take safety precautions until it was too late. And this has resulted in thousands of thyroid cancer cases and up to 15 deaths so far from preventable cancer. The cesium, however, is maybe a more problematic health effect. It's one of the most problematic hazards associated with nuclear disasters and nuclear radiation in particular, as it does bioaccumulate up the food chain. And it has a half-life of about 30 years. So it takes a lot longer to decay away and no longer become a problem. You have to wait almost 100 years before it's down to more negligible levels. It accumulates, therefore, in the upper layers of soil and can be taken up by plants and fungi. Wild boars who feed on these fungi will become contaminated with it. In Central Europe, for example, it's not uncommon to find boars with radioactivity levels on the order of 1,000 becquerels per kilogram of body weight. And that's about, say, 10 times higher than the natural radioactivity levels that are in everybody's body from just naturally occurring elements. Interestingly, recent research just published, like within the last month, shows that the source of this long-lived radioactivity is not mainly the Chernobyl accident. Scientists have compared the isotopes of cesium and found that between 10 and 68% of this radiation in European boars was from fallout from open-air nuclear weapons testing back in the 50s and 60s. The contaminants from both the weapons tests and the Chernobyl disaster seep into the soil and are absorbed by underground fungi like truffles that the pigs love. So this is a particular problem that people have to take account of in these situations, and it's not good. But the levels are relatively low. 10 times more than what we actually have in our bodies is not something that is known or to cause measurable impacts on people who eat that boar meat. However, safety levels have been set about 100 times lower than measure where the measurements actually are known to cause problems, just because they can set these levels low, and you want to make sure that you aren't inadvertently exposing someone to ill health. So, thinking back to Fukushima, the Fukushima Daiichi cooling water has now been treated to remove heavy radioisotopes like cesium, but radioactive impurities remain, and it's mainly tritium. Now, tritium is an isotope of hydrogen, and hydrogen is, of course, typically a single proton. A hydrogen atom consists of a single proton. Well, tritium is a single proton with 2 neutrons, so it's 3 times the mass of hydrogen, but it interacts chemically just like hydrogen, so it can be bound up in water, and you can have heavy water with tritium in it, and it will give off radiation. Tritium has a radioactive half-life of about 12 years. So it spends some time in the environment before it goes away. But its route of radioactive decay is not high-energy gamma rays. It only gives off low-energy beta particles. So it basically pops out a helium nucleus. And these things are relatively low. They don't have any penetrating power. You can stop tritium with a piece of paper. Tritium radiation doesn't penetrate paper. And it doesn't accumulate up the food chain. It's just water. Water comes into our bodies. It goes out. We urinate. We excrete water quickly. After 40 years, it's mostly no longer radioactive. It also occurs naturally in the oceans, in nature. It's created by cosmic rays interacting with the upper atmosphere, and it drips down to the earth in rain and ends up in the oceans, of course. So Fukushima, TEPCO, the company that operates Fukushima, has been collecting the cooling water from the cores in tanks. There's a couple hundred tons accumulating every day since the meltdown in 2011. Now, all of this water contains some tritium from the radiation in the cores. And it's estimated that in this 1 million tons of water, there's about 1.8 grams of tritium. That's it. In 2013, TEPCO built a processing facility called the Advanced Liquid Processing System, or ALPS, to remove all the bad stuff, all the heavy ions that were in the water from the core, because there's lots of radioactive compounds just free in those cores. To put this amount of tritium into perspective, however, the natural global inventory of tritium in our atmosphere is about 7.3 kilograms worldwide. So 1.8 grams of this stuff is in the wastewater of Fukushima. There's 7.3 kilograms around the world. So what's the process? How dangerous is it that TEPCO is planning to release this back into the ocean? Well, they've had a process approved over the years by the International Atomic Energy Agency to slowly release this processed cooling water after it's gone through the ALPS process to remove the heavy ions over a period of about 30 years, while diluting it to a final radioactivity which is less than 1/40th that of safe drinking water standards. The rates of emission are lower than what the plant itself would have emitted while operating. All nuclear plants create tritium, and TEPCO Fukushima was no different. So this is basically releasing levels of tritium back into the water similar to what it would have done while operating. Of course, news headlines around the world are trumpeting the dumping of 1.3 million tons of radioactive waste into the ocean. Meanwhile, there are huge protests around the world stirred up by the media's uncritical acceptance of outrage from China and anti-nuclear Greenpeace. A recent article in The Guardian shows how China has been manufacturing anger through a steady stream of state-backed propaganda. Fake or misattributed videos have claimed sea life is turning up dead on the beaches, that there have been mass protests, and that a Japanese official who drank the treated water from Fukushima at a 2011 press conference had died. Some other examples have been collated by an Australian-based China analyst on TwiX, as I call it, which is formerly Twitter. And this includes footage of a rally in South Korea, reported by Chinese state media as being in Japan. And fake news about a Japanese politician apparently suggesting Chinese visitors should be made to eat shellfish from Fukushima. So polarization is being generated by state actors preying on radiophobia to score points. What else do we know about this manufactured storm of media? A study by the UK-based data analysis firm Logically found there were high volumes of state media reports and paid advertisements in multiple languages about the risk posed by this wastewater. It found unique posts about the topic on social media by Chinese state media officials and influencers. And these peaked at more than 3,500 in July of 2023 this year, with some garnering more than 1 million views each. In the last week, there have been reports of rocks and eggs thrown at Japanese schools in 2 Chinese cities, abusive phone calls to Japanese businesses, and social media campaigns to boycott Japanese products. This prompted Japan's government to summon the Chinese ambassador and urge caution among its China-based citizens. After the most recent spate of hostility, the Japanese government has taken the extraordinary step of warning its citizens not to speak Japanese too loudly in China. Embarrassingly, however, publicly available data on Chinese nuclear reactors shows that the amount of radioactive tritium in wastewater being released from Chinese nuclear plants, recorded at 13 of the nation's monitoring points in 2021, surpassed the maximum allowable annual amount of the material contained in treated water set to be released from the Fukushima plant. However, rationalities shall not enter into the public domain. Some scientists have also suggested the risks haven't been studied in enough detail. TEPCO's assurances are not supported by the quantity and quality of data that they originally revealed back in 2021 when this plan was announced. Some scientists have suggested that dumping tritium in the ocean is unsustainable. Certainly, dumping of nuclear waste in the ocean was seen as a major problem in the mid-20th century and is one of the main motivators of anti-nuclear environmental groups. Check out my previous podcast if you want to learn more about that. There's a marine biologist in the news who's expressed concerns of tritium becoming bound to tissues of marine life and then bioaccumulating up the food chain. Is this reasonable to expect? I did a quick search of scientific literature on organically bound tritium, and I found a 2019 study on rats that were fed relatively high levels of tritiated water in the kilobecquerels range. And the authors of that paper found that the biological half-life of tritium in the rats could be distributed between tissue-free water tritium, which is water that's not bound up, it's just in the body, and organically bound tritium. And the half-life of these things in the body was about 2.1 and 5.9 days, respectively, before it gets re-emitted to the environment. So this isn't a long time. It's not able to do a whole lot of damage in that time period. And also remember, it does not penetrate very far. So only if it's localized in one region and builds up would it really be expected to cause a lot of damage. Furthermore, they looked at the rat cells to determine if there was evidence of genetic damage, and a commonly used indicator of micronuclei, I'm not familiar with this, showed no impact of drinking water with 37 kilobecquerels of tritium activity in it. So why is there so much concern? Well, TEPCO has a reputation for being less than open. It's lost the public's trust. It's made poor decisions on citing its backup diesel generators. And it hasn't been that open with its data releases. It was responsible for safety failures at the plant. The record isn't stellar. The data it released back in 2021 represents less than a quarter of the tanks, and it includes measured concentrations of tritium and only a limited number of other radionuclides. Strontium-90, cesium-137 have turned up in wildly varying concentrations in these earlier measurements, raising questions about how well their filtration system works. Scientists critical of the current plan have proposed several alternatives to consider. One is just letting it evaporate. That is not really feasible due to the limited area on site, or so the TEPCO representatives will have us believe. One option is bioremediation, pumping wastewater through tanks full of oyster species that consume plankton and incorporate radionuclides into their shells, reducing the time needed for storage. Of course, I don't see that as a great solution. Anytime you bring life into it, you have problems, and it makes it much more complex to track. Another idea is to use the water to make concrete for roads or bridges using the tanked water. This seems to have many benefits and would be an appropriate usage of it. It would accelerate water processing and removal from tanks and not impacting any fishing industries or not enticing people to protest over that and slowing the spread of protests. Also, it's non-transboundary. It doesn't use a global commons as the solution for pollution being dilution. This process helps to protect the environment by safely containing the tritium inside the concrete, and it also saves a significant amount of fresh water. However, the TEPCO officials have decided to go forward with dumping the water and diluting it, which is probably the cheapest method of getting rid of it. Is this safe? Well, the IAEA, the International Atomic Energy Agency, recently published the results of a multi-laboratory study verifying TEPCO's measurement accuracy on all of the reported radionuclides measured in their tanks. Activity levels of all of the heavy ions in this most recent 2023 study beyond carbon and hydrogen were well within safety limits. The ALPS process doesn't remove carbon or hydrogen. There's not a lot of carbon to begin with. There was no graphite in this system, so it's not a big component. Tritium is the main contaminant at this point of those tanks that were studied in the 2023 data. And the 2023 IAEA report from January outlines the following plans. This is their plan. Existing ALPS treated water varies in radiological composition due to a variety of factors, including the time when it was first generated and with what generation of ALPS treatment it was originally processed. Therefore, a secondary ALPS treatment process line will be established that will treat water currently stored on site as necessary. This water will be processed through the ALPS facility until it meets the criteria for discharge included in the authorization. To verify this, TEPCO will organize the existing K4 tank group into 3 sets of 10 tanks each. Each tank set will be assigned to one of 3 rotating functions: receiving water from the ALPS process line, holding water that is pending analysis results and confirmation of its contents, and holding water that is ready for discharge. So they're going to release the water in batches and test it to see if it is still radioactive, if all of the bad stuff has been removed. The water that is deemed ready for discharge will be connected to piping that transfers the water down to sea level, where it will be mixed with incoming seawater from the surrounding area. Seawater will be pumped in through the old Fukushima Daiichi Nuclear Power Station Unit 5 water intake port. The seawater and the ALPS treated water will be mixed in a mixing well in a seawater pipe header and then discharged through an undersea tunnel out to approximately 1 kilometer from the shoreline. The discharge point identified by TEPCO is located in a zone restricted for commercial fishing. The chosen operational parameters for the discharge include an annual limit of 22 terabecquerels of tritium and a concentration limit of 1,500 becquerels per liter tritium in the discharges. The Japanese nuclear regulator, called NRA, uses 2 different dose criteria to approve the TEPCO release plan. One from their Reactor Regulation Act, which is a 1 millisievert per year from a hypothetical extreme situation at the site boundary, and another criteria established for the ALPS treated water discharges of only 50 microsieverts per year exposed dosage to a representative person using typical habit data in relation to the region that the water is being discharged. So to put this in perspective, sieverts are another issue of radioactive dose. The global natural background radiation that we all receive is about 2 millisieverts per year. So what they've said the worst case accident of a hypothetical extreme situation of someone hanging out and living at the boundary of the radiation site is 1 millisievert, so half of your annual dose in a year. So, this all seems very low and very safe. Statistically significant increases in cancer rates start around 100 times higher than these levels. So this is giving you some idea of how safe this water is. So I think in summary, what we have here is an easy target for fearmongers to score political points due to the problems of the global radiophobia epidemic. Is it a problem that Japan is releasing water that is safe to drink into the ocean? Certainly, we don't want to see nuclear radioactive materials being distributed into the ocean frequently. I think the data here, however, is clear that this is a tempest in a teapot. There are bigger problems that we should be worried about. The truth is out there, if you have a rational view.
If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/therationalview. Thanks for listening.